Hello, everyone. Welcome to Introduction to Amazon EFS Replication, session STG 303. My name is Abrar Hussain. I'm one of the principal product managers on the Amazon EFS team. And I'm joined by Prateek Parekh, who is a senior product manager also on the Amazon EFS team. He will be coming over later today, later in the session to talk about Amazon EFS Replication. We're both very super excited to talk about Amazon EFS Replication, a pre-announcement that we have done at re:Invent. So let's get started. Amazon EFS Replication is coming soon to your favorite AWS region. It automatically and transparently replicates your EFS file system to a second file system. You can select an availability zone or a region of your own choice. EFS Replication is designed to help you meet your business compliance and business continuity goals by helping you achieve RTO and RPO of minutes. Yes, you heard it right, I'm talking about minutes. We're going to dive deeper into all of these things in the session and find out how you can do all of that. So in this session, we're going to start off by giving you a quick primer on Amazon Elastic File System, your cloud-native Elastic File System. Then we're going to talk about your disaster recovery and compliance requirements. And we're going to discuss how Amazon EFS Replication will help you meet those compliance requirements. We're going to talk about customer use cases as well, how we see our customers use Amazon EFS Replication. And we are excited to do a live demo. It is exciting, and it's also nerve-wracking at the same time. But Prateek was brave enough to volunteer for it, so we are ready for doing a live demo today. At the end, we're going to talk about the best practices for Amazon EFS data protection, the comprehensive data protection for your EFS file systems, and we'll leave you with a summary and a call to action. If time permits, we will also do a live Q&A, and if time does not permit, we'll be available here for offline Q&A as well. So with that said, let's start with the actual sessions. Oh, by the way, before I get to the actual sessions, these are all the Amazon EFS sessions that are happening at re:Invent today. We have sessions at 200 level, we have sessions at 300 level, and 400 level as well. So for example, at a 200 level, we will be talking about AWS storage solutions for containers and serverless. That's going to happen at 7 p.m. later today. We're going to be doing a deep dive on Amazon Elastic File System tomorrow at 11:30 a.m. So that's another interesting session that you would like to consider. We're also going to be doing a session on enhancements to Amazon EFS performance. So a lot of sessions to choose from. Please take a photo of this. If you missed the session, some of these sessions may also be available for you to view online later. Okay, so first, let's do a quick primer on Amazon EFS. Sure. I will be showing this slide one more time if needed later on. Okay, so we're going to do a quick primer on Amazon Elastic File System. We launched EFS back in 2016 to give our customers a simple, serverless, set-and-forget, cloud-native Elastic File System. It is super simple to use. You can get your file system created in seconds and in as little as 2 clicks. EFS is cloud-native by purpose and by design. It is built from ground up in the cloud to be simple at cloud scale and to be fully elastic. It grows or shrinks based on business demands automatically, and you only pay for the capacity that you use. It can elastically scale up to tens of petabytes. Scaling to tens of petabytes is a good thing, but being able to do that elastically, that is bar raising. EFS is also serverless. It is infrastructure free. You don't have to think about managing or operating storage infrastructure. You don't have to think about provisioning or sizing storage. This allows you to focus on accelerating your business innovation and removing the need to spend cycles on undifferentiated heavy lifting of managing your infrastructure. EFS is also secured using cloud constructs like AWS Identity and Access Management, resource policies, access points, and AWS KMS. So you can control access to the client and you can control or enforce behaviors like encryption. And it is protected with cloud constructs like AWS Backup to allow you to centralize and automate your data protection at cloud scale. One of the things about EFS is that it's consumable from any AWS computing model. And you can do that at scale. It supports tens of thousands of concurrent connections independent of the type of model you are using. It could be serverless, it could be containers, it could be EC2 instances as well. EFS could be consumed across all of these connections concurrently, and you can take the connections, scale the connections up to tens of thousands. Next, I want to talk about cost optimization. EFS is cost optimized. It provides 4 storage classes with different price and performance characteristics. It comes with automatic lifecycle management to transition your infrequently accessed files to a lower cost, infrequent access storage classes. And it offers intelligent tiering to optimize your use cases for variable access patterns. We have one-zone storage classes that are priced at 4.3 cents per gigabyte per month on a blended storage cost point of view. This is based on industry average that 20% of the files are frequently accessed and 80% of the files are infrequently accessed, giving you a blended storage cost of 4.3 cents per gigabyte per month. And lastly, I want to talk about performance. EFS is performant. It offers latencies as low as 1 millisecond. You heard me right, as low as 1 millisecond. And it can scale up to tens of gigabytes per second of throughput and support over 500,000 IOPS. So finally, EFS is also designed to be highly durable and is highly available. It is designed for 11 nines of data durability, and it offers an availability SLA of up to 99.99%. Okay, so next we're going to dive a little bit deeper into EFS storage classes. It is important to understand storage classes before we can understand replication. So EFS offers 4 storage classes, and they work in pairs. We've got 2 one-zone storage classes, EFS one-zone and EFS one-zone IA, and we've got 2 standard storage classes, EFS standard and EFS IA storage classes. The one-zone storage classes are low-cost and low-latency storage classes. The standard storage classes are multi-AZ regional storage classes. However, both the storage classes offer high durability and high availability, but there are differences. So let's do a quick comparison. The one-zone storage classes redundantly store your data within a single availability zone and are designed for 11 nines of durability. The standard storage classes redundantly store data within and across availability zones and are also designed for 11 nines of durability. So while the one-zone storage classes offer an availability SLA of 99.9%, the standard storage classes offer an availability SLA of 99.99%. So that's 4 nines. Now with a blended storage cost of 4.3 cents per gigabyte per month, one-zone storage classes are 47% lower cost compared to standard storage classes, which has a blended storage cost of 8 cents per gigabyte per month. And then from a file operations latency perspective, both one-zone and standard storage classes offer read latencies as low as 1 millisecond. And since data is stored in a single availability zone for one-zone storage classes, they offer write latencies as low as 2.4 milliseconds, which is 35% lower than the write latencies offered by standard storage classes. So that's how you can think about the 2 different sets of storage classes that EFS provides. Now that we have a primer for EFS, we understand the storage classes, let's start talking about the requirements that you have, your compliance and your business continuity goals. So to better understand your compliance goals, your business continuity goals, your disaster recovery goals, it is first useful to understand what do we mean by RPO and RTO. RPO is recovery point objective, RTO is recovery time objective. But even before that, let's quickly understand what is a recovery point. A recovery point is a point in time representation of your data. So a recovery point objective then is the maximum acceptable time since the last recovery point and a potential interruption of service. That's what a recovery point objective is. A recovery time objective, on the other hand, is the maximum acceptable delay between the interruption of service and the restoration of service. So you want this window to be as small as possible. You want this window to be in minutes. So now let's talk about your compliance and business continuity goals. Your business needs data protection compliance requirements. You need to maintain a copy of your file system that is separated hundreds of miles apart from the source file system. You also need to build a DR strategy accommodating these hundreds of miles of geographic separation and achieving or meeting an RPO of minutes. And then the most important part, to maintain business continuity, you need to achieve RTO of minutes post interruption of service. So these are your compliance and business continuity goals. Now, a lot of our customers have been building time-consuming scripts, building automation to monitor and synchronize data changes, and in some cases, they're deploying and maintaining their own infrastructure to execute replication. However, this self-managed replication comes with its own challenges. Self-managed replication adds operational overhead to your business, and it is undifferentiated heavy lifting, and we do not want you to be doing the undifferentiated heavy lifting. And then the total cost of ownership is high, as you end up maintaining at least 2 copies of your data without any cost optimization. And then despite all this overhead, many customers are still not able to meet the required RPO and RTO objectives. And that's where Amazon EFS Replication can help. So let's dive a little bit deeper into Amazon EFS Replication. Like I said, it's coming soon to your favorite AWS region. Amazon EFS Replication automatically replicates your EFS file system data to a second file system. Just like Amazon EFS itself, Amazon EFS Replication is also very simple to use. Previously, I told you that you can create an Amazon EFS file system in just 2 clicks. Well, guess what? You can also configure your Amazon EFS Replication in as little as 2 clicks. You can select the destination region or availability zone of your choice. EFS Replication provides a lot of flexible replication options, and we're going to talk about what these options are shortly. It is flexible. It enables you to meet your compliance and business continuity goals by achieving RPO and RTO of minutes. EFS Replication is transparent. You can monitor and alarm on the replication status using Amazon CloudWatch. I'm going to show you how this works as well. Okay, so how does EFS Replication work? You can enable EFS Replication on any existing EFS file system. And when you configure your EFS Replication, a read-only replica is automatically created for you in the selected region, and the changes of your file system are transparently and continuously applied to your source file system, to your destination file system. You can configure your destination file system settings like provision throughput, mount targets, independent of the source file system as well. You can use the AWS console, the API, or the CLI to enable your replication, and you can also initiate your failover to the replica. So depending on your business needs, you can use EFS Replication to replicate your file system within the same region or across into a different region. So as an example, you can replicate your EFS 1 zone file system, let's say from AZ1 or AZA to AZB within US East 1 region. You can also replicate your 1 zone file system to a completely different AZ and a completely different availabilities, in a completely different region as well. As another example, you can replicate your EFS standard storage classes across region from US East 1 to US West 2. In fact, this is one of the examples that we will see in our demo today. So you can replicate your EFS file systems within and across AWS regions. Previously, I told you that EFS Replication provides a lot of flexible options. Let's talk about what those options are. You can set up your destination file system independent of your source file system. So you can replicate from a source file system created using Amazon EFS standard storage classes to a destination file system created using 1 zone storage classes. And yet you can also do it the opposite way too. You can select your destination file system's lifecycle management policy, backup policies, provision throughput, resource policies, and access points independent of your source file system. So for example, you can optimize the destination file system storage cost by enabling lifecycle management policy with a shorter age-off policy, like 7 days, for example, when compared to the source file system that has a more higher age-off policy, which could be 14 days, 30 days, 60 days, or even 90 days. So you have flexibility in configuring the settings of the replica file system compared to the source file system. So previously we talked about your compliance requirements, your disaster recovery requirements, your business continuity requirements. Now let's take a deeper look at how EFS replication can help you meet those requirements. To meet your disaster recovery requirements, Amazon EFS replication is continuously replicating your data from source to destination and is designed to provide you an RPO of minutes for most file systems. You can select your source file system and a destination region of your choice and meet the hundreds of miles apart geographic requirement that your DR strategy has. And then while replication is happening, your destination file system is also highly available with an SLA of up to 99.99%, but it is available in read-only mode. So you can still mount that file system, still use it. It is in read-only mode while the replication is active. So by allowing you to meet an RPO of minutes, we're able to help you meet your disaster recovery requirements with Amazon EFS replication. Next, to meet your business compliance requirements and also for validating your disaster recovery readiness, EFS replication uses Amazon CloudWatch to allow you to monitor and alarm on your replication health status. Now, what do I mean by replication health status? Well, the main reason why you're doing Amazon EFS replication is because you want to meet the RPO of minutes. So you got to be able to monitor that. And that's what you can do with Amazon CloudWatch. So here is a screenshot of the CloudWatch environment. You can monitor and alarm on your RPO achievement, which is measured in minutes. So the time since last sync metric represents the duration of time in minutes since the replica was last synced with the source. So this represents your RPO essentially, right? So you can set an alarm to alert you if the last sync time is over 15 minutes. So if the RPO is breaching 15 minutes, then you get an alarm, you get a notification. So this will help you meet your compliance requirements, and you will always be alert if the RPO is not meeting your requirements, and you're essentially ready for your disaster recovery. So let's talk about your business continuity goals, right? To meet your business continuity goals, Amazon EFS replication is also designed to provide RTO of minutes. So like I said, while replication is already happening, your destination file system is available, but it's available in read-only mode. You can still use it. But in the event of a disaster, you can fail over your business critical application, for example, from US East 1 to US West 2. And within minutes, your destination file system is made available in writable mode, allowing you to continue to run your business critical application with minimal interruptions. So the window that we talked about previously, the RTO and RPO window, we have essentially minimized that window to minutes. Okay, next look at how we see some of our customers use Amazon EFS replication to optimize their DR cost and to increase the availability of their business critical applications. So you can cost optimize and save up to 72% in DR storage cost by enabling lifecycle management on the destination file system with a shorter age of policy, example 7 days, when compared to the source file system's age of policy, which could be at 30 days. So we're talking about saving 72%. Let's do the numbers to see how that works. We're going to use a 100 terabyte EFS standard file system. So an EFS standard file system in US East 1 region with 80% of the files infrequently accessed and a 30-day lifecycle management policy will help you achieve a blended storage cost of 8 cents per gigabyte per month. So at this blended storage cost, a 100 terabyte EFS file system is going to put you at a monthly storage cost of $8,192. So that's how much you would be paying for your primary EFS replica file system that is of 100 terabytes. Now, for the destination file system in the US West 2 region, you can expect that a higher percentage of the files are going to be infrequently accessed. It is your replica. It's not being actively used. So you can expect that 95% of the files are going to be infrequently accessed. So out of that 100 terabyte of data, 95 terabyte of the data will be stored in the standard IA storage class. Now, with an aggressive 7-day lifecycle management policy, you can achieve a blended storage cost of 2.2 cents per gigabyte per month, putting you at a monthly storage cost of $2,223. You can cost optimize further and save up to 85% by using one-zone storage classes for your destination file system and enabling lifecycle management policy with a shorter age-off day, which is 7 days, when compared to the source file system, which could have an age-off policy of 30 days. So let's do the numbers again. We're going to use the exact same EFS file system in the source region, 100 terabytes of EFS file system, standard file system. And as we just established, the estimated storage cost of that standard file system comes to $8,192. Now, for your destination file system in the US West 2 region, we're going to use one-zone storage classes that offer 47% lower cost compared to standard storage classes. So they come at a blended storage cost of 4.3 cents per gigabyte per month. And with a expected higher percentage, 95% of the files that are going to be infrequently accessed, and a 7-day lifecycle management policy, you can achieve a blended storage cost of 1.2 cents per gigabyte per month, putting you at a monthly storage cost of $1,183. That is 85% in cost savings for your destination EFS file system. I think that's really cool. Well, I'll take questions towards the end if that's okay with you. Thank you so much. So we've got customer use cases not only around cost, but we also have customer use cases around availability. Right? Like I previously said, EFS one-zone storage classes are highly available. We've got 3 nines of availability SLA with our one-zone storage classes. But I also said that EFS one-zone storage classes redundantly store the data within a single availability zone. So since they're storing the data in a single availability zone, the file system may not be available in the event of a disaster that affects all copies of that data in that availability zone. So you can increase the availability of your applications that are using one-zone storage classes using cross-AZ replication. So for example, you can replicate your one-zone file system from AZ-A to AZ-B within US East 1. So what happens? In the event of a disaster, you can maintain your business continuity by failing your business application to use the replica file system in AZ-B. And subsequently, you have now increased the availability of your business critical application and still are able to use EFS one-zone file systems. I've got one more customer use case that I would love to share. Customers with global research and development locations often run their dev test environments in a completely different AWS region from where they're running their business application. So that means the dev test environment will need cross-region access to your EFS file system, and that can introduce network latency. So you can optimize on your network latency by replicating your file system to the region where your dev test environment is located, and by configuring your dev test environment to use the replica file system instead. And that way you have optimized on your network latency. There's also one more use case that I do not have on the slide. You can use your replica or the destination file system as a file drop-off location. So for example, you would be replicating from your source file system to your destination file system. But like I said, you can have independent configuration on your destination file system. So you can have EFS access points on the destination file systems, and as files are getting synced to the destination file system, you can use those access points for customers or your clients to pick up specific files, and you can use access points to enforce identity, to enforce a specific directory to be a root directory. So that's another cool use case of EFS replication. And honestly, we cannot wait to see what else you will do with EFS replication. Okay, so enough said. We've talked about what EFS replication is. We've talked about how it will help you meet your compliance, business continuity, and disaster recovery goals. Now it's time for that live demo. Now, in the true spirit of replication, we have also replicated this live demo into a recorded demo, just in case if there's an event that prevents us from doing the live demo successfully. For that, I'm going to invite Pratik to show us a live demo.
So here I have a source file system that I'm going to use that I created already, and it's serving a web page just so that we can see how data is moving. So what I'm going to do immediately is I'm going to go in and show you that my web page, this is the web page that it's loading, it's using. And now I'm going to enable replication on this file system. So what I want to do in this demo is to replicate my file system. We'll observe the destination file system and see the data is moving over there. We'll then perform incremental replication so that we can see the incremental data is also moving over to the desk. And then finally, we'll try to perform a disaster scenario wherein our source file system will not be available, but we will still be able to serve the web page using our destination file system. Okay? So let's go ahead and create replication. So this is my EFS console. On the bottom right, you will see the replication tab, and I am going to go ahead and create replication. So one of the first things you need to decide is where do you want to store this replica. In my case, I want to store this replica thousands of miles away from my source file system, so I'm going to pick US West 2, given that my source file system is in East 1. So there you go, I picked US East 2. I'm going to leave my replica to be a regional file system, and then all destination file systems that are created encrypted at rest. So if you have a key that you want to use, you can enter it here. If not, we will use a default key in that region. And just as Abrar said, within 2 clicks, you can enable replication on your source file system. So let's look at the replication tab now. So here you see your replication tab is now filled out. Let's quickly go over some of the items here. So the replication state, as you can see, is now enabled. Meaning EFS replication is setting up the infrastructure to copy your data from your source over to the desk, and it's also performing the initial sync. So it's taking all the data that you currently have, and it's pushing it all to your destination file system. I'd like to draw your attention to this bottom half of the tab, where it shows the 2 file systems that are in this replication pair. The source file system is writable. Obviously, you're using it right now. The destination file system is read-only. And as Abrar mentioned earlier, you may have use cases where you want to replicate your file system over to a different region for quicker access, for a drop-off point. And EFS replication allows you to use that replica as a read-only file system right away. So let's quickly go over to the destination side now to observe this file system. And I also want to set the destination up so we can mount it. So I am going to click here. So very conveniently, you will be able to move over to your desk, right? As you can see, this is a read-only file system, right? And what I'm going to do first is, by the way, we are in the Oregon region, if you noticed. And I'm going to create a mount target here. So real quick, I'm going to pick the correct VPC and security group so that my mount target is correctly created. I'm going to move this over here so it's easier. Okay. All right, so this mount target is being created. So while this mount target is created, now let's go ahead and get those cost savings. So here you can see your replica is created. It's a general purpose file system with bursting throughput mode, but no lifecycle management has still been enabled on it. So let's go ahead and do that. So in my use case, I know I'm not going to access my dest file system. So I'm going to apply the shortest age of policies so that I can achieve the 72% cost savings that Abrar mentioned, right? And in the case of a disaster, I know obviously I'm going to start using my dest file system, in which case I'm going to enable intelligent tiering on my file system so that the data can be brought back into my standard storage classes from my IA storage classes, and I don't have to worry about unbounded data access charges on that. So I'm going to do that as well. And I'm going to save it. And that's it. That's all you need to do. Just configure your file system to be to save you money on the replica. The mount target is being created. Let's give it a minute. There you go. It's ready for me to use. So I am going to mount my file system to my EC2 instance that I am running on the US West 2. And I'm going to mount it on the directory where my Apache web server is running so you guys can see it. Okay, so I have mounted my file system. Now let's quickly go back to the source, and we said we are serving the web page, right? This is my web page on the source file system. As you can see, it matches my instance here, right? And let's go look at the state of replication at this point. We have enabled replication a while back. Is it done yet? There you go, it's done. So now let's go ahead and load the same on the dest side. So this is my US West 2 side of my replica. And our data is now moved over to the destination side. Right? Now let's perform a quick incremental replication exercise. So I'm going to go back to my source side, and I'm going to copy over another image so that we can see that it incrementally replicates over. So copy just another image. I need to zoom. Okay. And I am also going to update my HTML page just so that it displays the image. Nope. So I have my second picture here. Okay. So now when I load my web page again, I have my second picture on the source side. Now this will automatically be replicated onto the dest side. But before we do that, let's quickly take a look at the last sync field that we briefly touched upon earlier, right? So you want to maintain a certain RPO for your replication, and the way you measure that is through this field. This field is being published to CloudWatch, as Abrar showed you. This field tells you the time it takes for the replication to complete incrementally. So just like the set and forget promise of EFS, the replication feature itself is sort of a set and forget feature. Once you enable it, you don't have to worry about it, you don't have to manage it, and you can observe the RPO that your file system is maintaining through CloudWatch. So the lasting time is the time at which your source file system was copied over to the desk side, right? So the time between these two timestamps is essentially your RPO, and you can set a threshold in the CloudWatch metric to alarm if that time increases your RPO requirements. Now let's quickly observe if this data has been ported over, and it has, right? So now you can see the data has moved from your source to the desk quickly. Now, very quickly, let's do a quick disaster scenario. So what I'm going to do here is maybe stop my Apache web server, right? So on my source side, my Apache web server has been stopped. So this web page should now not serve. There you go. Okay, so what do? Disaster has struck. So at this point, what we want is, we want our desk file system to become writable. In our case, because we are serving a web page, it is actually still available for read-only access. But what we need to do in terms of failover is we need to break the replication relationship between the source and the desk, which we do here by deleting. And when you click delete on the source side, it actually takes you over to the destination side, because the understanding is that maybe something has happened in your source region, which is not, you may not be able to access your source region console. So once you do that, of course, it's a destructive action, so it asks you to confirm. So we confirm here, and we delete the replication. Now this action does take a few minutes, but it's still in minutes, and we may not be able to finish the operation in this demo, but we will still maintain an RPO of a few minutes with this action. So having said that, as you can see, now your desk is completely being served, right? So once that action finishes, your desk will be writable, and you should be able to operate from it. So this is a short demo that we wanted to show you. I will hand it back to Abrar to talk to us about the whole data protection strategy, and then wrap this session. And then we'll be able to answer any questions that you have. Thank you.
Prateek, thank you so much. That was brave, and that was a live demo. We did not need the recorded version of the demo. I know he was showing the pictures of beaches and stuff, but I'm sure all of us want to be here right now. I certainly do. Okay, so we just looked at the demo. So I want to wrap up the session by talking about data protection as a whole, comprehensive data protection for Amazon EFS. So when I was originally introducing Amazon EFS to you, I talked about EFS being protected using cloud constructs like AWS Backup. So at this point, you may be wondering, well, EFS is already protected using AWS Backup, so why should I use Amazon EFS Replication? The thing is, EFS Replication is designed to work alongside with AWS Backup for EFS to provide you with the comprehensive data protection, including retention, disaster recovery, and business continuity requirements to meet your compliance goals fully. So to understand how this works, how they work together, let's just do a quick primer on AWS Backup for Amazon EFS. So AWS Backup provides policy-based data protection and management to help you meet your compliance needs for data protection. With automatic tag-based policies, you can schedule your backups for your EFS file systems. AWS Backup is also cost optimized, just like the way EFS is. It can lifecycle your backups from warm storage to cold storage to help you optimize for your cost. With AWS Backup, you can set up cross-region, and cross-account backups. You can protect your entire Amazon EFS file system using AWS Backup, but that protection is primarily for accidental deletion of files by a user or an unintended override by an application. And then when it's time to recover, you can recover the entire file system, or you can recover select files and directories of that file system from your AWS Backup. So this is what AWS Backup does. Now what's important is to understand how EFS Replication and AWS Backup work together. Like I previously said, EFS Replication works alongside of AWS Backup to provide you with comprehensive data protection for compliance and retention and disaster recovery and business continuity goals. So there was one important requirement I mentioned retention. And that is important to understand. How long do you want to retain your recovery points? With Amazon EFS Replication, we create a single recovery point, right? That is the only recovery point. And every time we replicate, we sync from the primary to the secondary. That recovery point is also automatically updated. So in a sense, you only have a single recovery point with Amazon EFS Replication. You can do same region or cross-region replication. However, EFS Replication lets you meet RTO and RPO of minutes. That's important. And it's primarily designed for your disaster recovery and business continuity goals. So that's the important distinction of replication. It works alongside with backup because with backup, you can do same region and cross-region backups. You actually have multiple recovery points with AWS Backup. You can schedule how often do you want to take those recovery points as well. You can go as low as 1 hour. So AWS Backup essentially gives you an RPO of hours, RTO of hours. Depending on the size of the file system, it could take an hour to recover the file system. It could take an hour or so to back up the file system. So you have RPO and RTO of hours, not minutes. So that's one key distinction. And then AWS Backup for EFS is primarily designed to help you recover from an accidental deletion by a user or an unwanted application override of the application. So together, AWS Backup and EFS Replication gives you comprehensive, complete data protection. So let me summarize some of the things that we talked about today. We're approaching the end of the session. We'll also do a Q&A as well. I think we'll have enough time for that. So what are the top 5 takeaways from this session? So the first one, Amazon EFS Replication is coming soon to your favorite AWS region. So just stay tuned for that, please. Next, with Amazon EFS Replication, you can select the destination region or availability zone of your choice. It is continuous, it is automatic. You just need to do this one single selection. And you can do that based on your disaster recovery distance requirements. You're able to meet your compliance, disaster recovery, and business continuity goals and achieve RPO and RTO of minutes. And then lastly, you can use both Amazon EFS Replication and AWS Backup together for comprehensive data protection for Amazon EFS. So at this point, if you're not already using EFS, it is super, super easy to get started with EFS. You can create your EFS file systems in just 2 clicks. And as soon as replication is launched, you can start configuring replication on those file systems as well. EFS is free to get started if you're already an AWS customer. So we want you to enjoy your simple, set and forget, serverless, elastic file system with EFS Replication coming soon. Thank you. At this point, I quickly want to share this one more time. If you missed any of the sessions, you can go look at them. You can most likely also watch some of them online later too. So we have some time to do a live Q&A. We have about 13 minutes left, so I'll probably take 2 or 3 questions, depending on how big the questions are. So the floor is yours, guys. Please go ahead. Thank you. Thank you. Could you repeat the last part one more time? I would like to repeat it for everybody. That will be helpful.
When we create the source file system, and then after we
Yeah.
Now, source is not available in the data. At that time, we log into the console and manually delete for the code. Most of the time, people will maintain that code, infrastructure as a code. So how that time you can delete that? So others go to the manual console and delete, or there is a way to utilize the code to delete that.
Oh, sure. So if I'm understanding your question correctly, if there's a disaster and you want to delete the replication, do you always have to go to the console to delete the replication, right? No, that's not right. You can delete the replication from the CLI and API as well. So if you already have code written to do that, you can automate that via your scripting mechanisms. Does that help?
I was trying to say, like, okay, the source region is not available. Oh, it is showing you a definition of.
Exactly. So the moment you click delete replication from the source, right, because you would have that window, it automatically, you can actually go to the destination directly and delete the replication too. You don't have to be on the source region as well. Great. I think you had a question as well in the middle here.
Yes, it had to do with the cycle time, 7 days.
Yeah.
That policy, so that's not actually the time that you have when you delete it, but the time that you change it to different.
Yeah. So the question was about that 7-day lifecycle management policy that we talked about. So this is particular to the EFS storage classes. Like I said, they work in pairs, standard and infrequent access storage classes. So the lifecycle management policy is transitioning your files from standard to infrequent access storage classes. It is not deleting those files. The best part is your application does not have to change at all. The file system maintains the same namespace. So you will still be able to access that file that have moved to infrequent access, just like the way you would if that was still in standard storage classes. So no change to the namespace, no change to the application. The only reason why we would move that file from standard to infrequent access in 7 days is because you or the application has not accessed that file in 7 days, and therefore we will assume that the file has now become infrequently accessed. But if your application decides to access that file again because your access pattern changed, Prateek talked about intelligent tiering. With intelligent tiering, you place the file in the right storage class at the right time. So on the first access of that file, intelligent tiering will bring that file back up to standard storage class, which is going to help you from any unbounded access charges.
So that sounds good for the 82% savings.
Correct.
As soon as you touch it, it flips back. So why wouldn't you do that?
Yeah, exactly. Exactly.
So why would others choose longer than 7 days?
So some customers choose longer than 7 days for compliance reasons, obviously. For primary file system, customers use 30 days, 60 days, 90 days, because when the file has moved to infrequent storage class, there is a first byte latency associated with that. That is the only difference. So some customers have very latency sensitive applications that cannot tolerate that first byte latency. And this is a very small cohort of customers. So for those customers, they would rather have a policy for 30 days. But we're talking about the replica here. We're expecting replica to be used in the event of a disaster. So you shouldn't have to be concerned about, oh, do I need 30 days? 7 days is generally acceptable. That's what we expect.
Yeah, I was going to ask about the latency.
Yeah, of course. Go ahead, please. Yeah. So the question is, what counts as access to decide if a file should be moved to infrequent access storage class or not? Does replication trigger the access timer? Does backup trigger the access timer? So the thing about AWS Backup and EFS Replication is they do not use EFS limits. So they do not trip that timer that we are using to access the file system. So in that case, even if we have replicated the file system, and if the timer of 30-day lifecycle has expired, that file would move to infrequent access storage class. Go ahead, please.
So are you looking at the daytime? How do you determine the file has not been accessed?
how do we determine if the file has not been accessed in 7 days? So access time is one of the things, modification time is one of the things, read time is one of the things, but we don't particularly use that to decide. That is one of the data points that is used to make the decision. But that is the key indicator of if the file has been accessed or not.
Yeah, but the access time can be updated, like you want to do like metadata listing and
Correct, and that's not considered as access in that case. So that's why we have a separate timer as well, which is not published or available.
And second question is, you have plans to let the user configure the RPO?
Good question. Do we have plans to have user configure an RPO? I understand S3 has a similar functionality. At this point, it all depends on your feedback. Our roadmap is driven 90% by what customers say. So I will definitely take that as a feedback. We are going to be launching enhancements to replication next year as well. So that could be one of the things we would consider.
So in case of like a DR scenario, right, where you are basically usually breaking the associations, right, not breaking the replication, making the other side writable.
Correct.
How would I put it back together? Like, let's say the source AC comes back online,
Yeah.
right?
Yeah.
Will reestablish
Right. So the question is, once you do a failover in the event of a disaster, can you actually fail back again once the primary file system has come back? So in the first launch that we're expecting to do, we will not be supporting failback immediately, right? So you can fail over to your replica file system. The replica file systems becomes writable. If you would want to fail back to the source file system or resync the source file system, you would have to establish a replication relationship again. So failback is not going to be supported in the first version of replication that we will be launching. But that is something we would like to consider down the road. Correct. Yep, that is something we will consider down the road. I'm pretty sure that will be one of the important features a lot of our customers will ask. So we'll definitely do a +1 on that.
And you can also use data sync currently at the first launch to actually put the, pull the changes back into the source.
Yep. Question? Yeah, go ahead, please.
Oh.
Just please repeat the beginning one more time. Oh, yes, that's right. So the question is there a file size limit for moving files from standard storage class to infrequent access storage class? And the answer is yes. Small files are not typically moved from standard storage class to infrequent storage class. I'm sorry, I do not remember the exact number, but it's available online, or I can share it with you offline. I can just quickly look it up and share it with you. But there is a small size limit, yes. Yeah, I see. So the question is, if you have set up a lifecycle management policy of your destination file system to use infrequent access, let's say at 7 days, can you change that later? Yes, you absolutely can. Like I said, your destination file system is configured independently of the source file system. You could have a lifecycle management policy of 7 days the first time, but then you decide, okay, that was too aggressive. You can bump it up to 14 days if you like. You can change it.
And in fact, we do expect that in the case of a disaster, once you actually move over, you might want to change all of that to match what you had in your source. So that's a way.
Yeah, super easy. Just go to the console, edit the file system, and you will be able to change it. Yep. Please go ahead. Does EFS replication replace data sync? No, the answer is no. I mean, data sync has a lot of other useful use cases. A lot of our customers use data sync to migrate their data from on-premises onto EFS, onto S3. So data sync has a primary use case for helping our customers migrate data from on-premises to Amazon EFS. EFS replication is new and it's native to EFS. So we expect that EFS replication will have a a better RPO compared to data sync. I mean, you could still use data sync to replicate your source EFS file system to your destination file system, but you're going to have to manage that manually. And you may not be able to achieve the RPO that optimized EFS replication will deliver.
Yeah, and to add to that, because EFS is a native, replication is a native EFS feature, you will not have any limits that you may encounter with other services such as data sync.
That's correct.
So that's an added advantage, but obviously the use case is replication, and data sync has its own use cases.
It's coming soon. Just stay tuned, it'll be coming soon. Great, so we're approaching towards the end of the session. We've got like a minute left, so I think I'll take this opportunity to thank you guys for joining us and spending an exact hour with us. Super, super excited. Thank you.